Steady operating condition exists. Heat is transferred uniformly from all surface to the resistor. Q is equals to heat flow rate delta T is equals to 0.15 watts times 24 hour is equals to 3.6 watts hour. Surface area is equals to 2 pi d squared over 4 plus pi dl. Then substitute 2 pi times 0.003 meter squared over 4 plus pi times 0.003 meter times 0.012 meter is equals to 0.000127 meter squared. Heat flow rate is equals to heat transfer coefficient times surface area times surface temperature minus temperature of free-flowing fluid. To surface temperature is equals to temperature of free-flowing fluid plus heat flow rate over heat transfer coefficient times surface area. Then substitute is equals to 40 degrees Celsius plus 0.15 watts over 9 watts per meter squared times degree Celsius times 0.000127 meter squared is equals to 171 degrees Celsius. Heat transfer is steady since there is no change with time. Heat transfer is one-dimensional since there is thermal symmetry about the center line and no change in the axial direction. And thermal conductivity is constant and heat generation in the heater is uniform. Egen equals Egen over V wire equals Egen over pi r squared times L. Then substitute 2000 watts over pi times 0.0025 meter squared times 0.7 meter is equals to 1.455 times 10 raised to the power of 8 watts per cubic meter. Na 0.0025 ni si diameter kay ang ipangita kay radius man, then ang diameter nato kay 5 mm, ang radius sa 5 mm kay 2.5 mm man, then i-convert man nato si siya og meter mo ng 0.0025 meter. Then, temperature of free-flowing fluid equals surface temperature plus Egen r squared over 4k is equals to 110 degrees Celsius plus 1.455 times 10 raised to the power of 8 watts per cubic meter times 0.0025 meter squared over 4 times 20 watts per meter times degrees Celsius is equals to 121.37 degrees Celsius. Steady operating condition exists. Heat transfer uniformly from all surface of the transistor. Q is equals to heat flow rate delta T is equals to 0.2 watts times 0.24 hour is equals to 4.8 watts hour. Kay since ang gipangita kay kilowatts hour man mo nang i-divide natin siya og 1000 mo ng 0.048 kilowatts hour. Surface area is equals to 2 pi d squared over 4 plus pi dl. Substitute 2 pi times 0.005 meter squared over 4 plus pi 0.005 meter times 0.004 meter is equals to 0.000121 meter squared. 0.005 meter na siya o kanang 0.004 meter kay gi-convert man nato ang 0.4 cm to meter mo ng 0.04 o 0.5 cm to meter mo ng 0.005 meter. Heat flux is equals to heat flow rate over surface area is equals to 0.2 watts over 0.000121 meters squared is equals to 1959 watts per meter squared. Heat flow rate is equals to heat transfer coefficient times surface area times surface temperature minus temperature of free flowing fluid to surface temperature is equals to temperature of free flowing fluid plus heat flow rate over heat transfer coefficient times surface area is equals to 30 degrees Celsius plus 0.2 watts over 18 watts per meter squared times degrees Celsius times 0.0001021 meter squared is equals to 139 degrees Celsius.